You of some of the things we learned about the force of gravity. The universal force of gravity is one of the four fundamental forces in our universe. It turns out that the force of gravity acts between all objects with mass. So if we have two objects, mass 1 and mass 2, these two objects will exert a mutual gravitational force. Mass 1 will be pulled toward mass 2, and mass 2 will be pulled toward mass 1. In accordance with Newton's third law, these two forces are going to be equal and opposite. The strength of those forces depends on the value of your two masses and the distance between the masses. When you're measuring the distance between the masses, we go from the center of mass of each object, and we denote that value with the letter R. So when we put this all together, we find that the force of gravity between any two masses in the universe is equal to the product of the two masses. Since both of these variables are on the top of our equation, increasing either one of them will cause an increase in force. Because they are linearly related, doubling either one will cause a doubling of force. On the bottom of this expression, we have radius squared, the distance between our objects. So a bigger distance will cause a lesser force. Because it's a squared relationship, doubling the radius will cause the force to drop 4 times. To this, we add the universal gravitational constant, which is an indication of the strength of the gravitational force in relation to other forces. Our force obviously will come out in newtons, so long as we work in meters for our distance and kilograms for our masses. When we are dealing with gravity on a planet, oftentimes it is useful to lump these three terms together. Since neither of them will change, the mass of the planet and the radius of the planet, and if we're close to the surface of the planet, those three terms together can be lumped together into a single variable, which is sometimes expressed as little g. This will be the strength of the gravitational field at the surface of that planet. Now the force of gravity can be found by just multiplying the mass on the surface by the strength of the gravitational field at the surface. If you're not at the surface, you can still use this expression so long as you find the strength of the gravitational field at whatever radius you are from the center of the planet.